All right, we're being asked to graph this linear equation in two variables, y equals negative 2x plus 5. And I will do that. I'm going to do that with the slope-intercept conversation, or slope-intercept form conversation. But I first like to talk about is what we're dealing with here, just real quick. Okay, first of all, this is a relationship between two variables, x and y. One thing we could always do if being asked to graph or just deal with any equation like this is to choose some values for one of the variables and find the value for the other one. So for instance, I could plug in the points x equals 0, x equals 2, and let's say x equals 4, for example. And if you did that workout, I won't show all the steps, but I plug in 0 for this, I would get out a 5. If I plugged in a 2 into that function, into that equation, I'd get a 1. If I plugged in a 4, I'd get a negative 3 for y. Importantly then is that each of these solutions can be realized as a point. For instance, 0, 5 we call the y-intercept because it has a 0 for an x value, and we also can describe y that ends up being a y-intercept in just a second. But we're not going to do that right now. What instead we're going to do is do this kind of more advanced analysis of looking at this equation in terms of the slope-intercept form. Y equals mx plus b. This b value here is this constant coefficient, and this is the y value of the y-intercept, and the m is the slope. So let's graph it with that information. Above, what we have then is we have that our slope is negative 2. We always think of slope as a fraction though, so we need a rise and a run. This would be a negative 2 over 1. You also could give the negative to the 1 down here, but I'm going to deal with it in this way. And we also have this 5 right here gives us that the y-intercept is 0, 5. By the way, you'll notice that agrees with what we did over here. And in fact, you can think about why this number outputs the y-intercept, because if you plug in a 0 in for x, you will always obliterate this first term and just get this output right here. But nevertheless, here we go. 0, 5 is a y-intercept, meaning our line crosses the vertical or y-axis here at 5. Then I want to talk about applying this slope. So what I want to do is to find multiple points to graph this. In fact, if I have 2 or more points, I can easily draw the line that connects those points together. The slope says negative 2 over 1. This negative 2 means go down 2 units, and the plus 1 here means go right 1. And those are directions to our next point. So I'm going to do that over here on the graph. I'm going to start at our point at 0, 5, go down 2 and over 1, to this point right here. This point, which is 1, 3, is a second point. I'm going to do that again just to get a couple points here. I'm going to go down 2 and over 1. And again, that down 2 over 1 information is read simply from this one number right here. Again, what I do is I treat it like a fraction, and I read these as directions. Down 2 to the right 1. Again, a positive 2 would have been up, but this is a negative 2, so I'm going down. A negative 1 would have been go to the left, but a positive 1 is going to the right. And then if I can do this without looking ridiculous, I'm going to try to sketch the line that connects these dots. This is, you would be amazed how hard this is to do on this computer. That is a beautiful line representation right there. The big point being, I started with my y-intercept, I applied my slope and got these additional points and drew a beautifully straight line through those points. Last to say is that you can see where these solutions come. In fact, I've found this solution right here that when I plug in 2, I get out 1. That was this point right here. Also, I got an additional one that I didn't find. If my x value is 1, the y value is 3 right there. That would be an additional solution I have. And in fact, just to recap, that line represents all of the possible solutions. This is 4 out of an infinite number of pairs of x and y that can be plugged in for x here and y here to make this equation true. This line represents all of those possible solutions.